Ever wondered how a jet engine works? It's a fascinating piece of machinery that powers the airplane and keeps us soaring through the skies. Think of a jet engine like a giant vacuum cleaner, but instead of sucking up dirt, it inhales air. This air is critical because it provides the oxygen needed for combustion, the process that creates thrust. When the jet engine starts, it pulls in air through the front, much like how you inhale through your nose. This air then gets compressed by a series of fans, which squeeze it tightly, increasing its pressure. Imagine squishing a balloon. The more you compress it, the more energy it holds. That's what happens to the air in the engine. And here's the surprising part. After compression, the air mixes with fuel that's sprayed in like a fine mist. This mixture is ignited, creating a powerful explosion. But don't worry, it's perfectly controlled. This explosion rapidly expands and pushes the hot gases out the back of the engine, propelling the airplane forward in the opposite direction. It's a classic example of Newton's third law. For every action, there's an equal and opposite reaction. As a result, the jet engine produces an immense amount of thrust, allowing the aircraft to climb high and cruise at incredible speeds. Each component is designed to work together seamlessly, making flying one of the safest modes of transportation. So the next time you board a plane, remember that a cleverly designed jet engine is what makes your journey possible. At its core, a jet engine works like a giant vacuum cleaner. Imagine how a vacuum pulls in dirt and dust from the air. A jet engine does the same thing with air. As the plane moves forward, air flows into the engine through the front, called the inlet. This is where the magic begins. Once the air is inside, it doesn't just sit there. The engine has a series of fans that compress the air, squeezing it tighter and tighter. Think of it like squeezing a sponge to get every last drop of water out. This compression makes the air super dense, which is crucial for what comes next. Now here's the surprising part. When that compressed air reaches a certain point, it mixes with fuel, just like when you combine ingredients to bake a cake. This mixture is then sent into a combustion chamber, where it meets a spark. When the spark ignites the fuel, it creates a powerful explosion. But don't worry, this isn't like a bomb going off. Rather, it's controlled and happens continuously. The explosion generates a blast of hot gases that expand quickly. Picture a balloon filled with air. When you let it go, the air rushes out, propelling the balloon in the opposite direction. In a similar way, those hot gases shoot out of the back of the engine, pushing the airplane forward. This is called thrust, and it's what keeps the plane in the sky. So to sum it up, a jet engine sucks in air, compresses it, mixes it with fuel, ignites it, and uses the resulting expansion to create thrust. Compresses it, mixes it with fuel, ignites it, and then blasts out gases to propel the plane. It's a brilliant cycle of energy that keeps us flying safely at incredible speeds. Curious to learn more about how this power is controlled? Don't forget to subscribe for more insights into the fascinating world of aviation. How does a jet engine turn air into thrust? It all starts with four main stages: intake, compression, combustion, and exhaust. Let's break it down step by step. First up is intake. Picture a giant vacuum cleaner, but instead of sucking up dirt, it's pulling in air. As the aircraft moves forward, air enters the engine through the front openings. This airflow is crucial because without it, the engine wouldn't have the oxygen it needs to burn fuel. Next comes compression. Once the air is inside, it needs to be squeezed to pack it tight. Imagine you're trying to fit a big sponge into a small container. The compressor does exactly that. It uses a series of spinning blades to compress the air. By squeezing this air, we not only increase its pressure, but also its temperature. This is key because hotter, high-pressure air burns fuel more efficiently. And here's the surprising part. This compression stage is incredibly effective. The air can be compressed to more than 30 times its original pressure. That's like cramming a balloon so full that it's ready to pop. Now that we have high-pressure hot air, we're ready for the next stage, combustion. But that's a story for another time. For now, just know that these first two stages, intake and compression, are essential steps on the journey to transforming air and fuel into the powerful thrust that lifts planes into the sky. So to sum up, the jet engine starts by sucking in air and compressing it to create the conditions for combustion. Isn't it fascinating how these stages work together? Stick around, and we'll explore the next phase soon. Now, here's the surprising part. The combustion stage is where the magic truly happens. After the air has been compressed, it meets fuel in a combustion chamber. Think of this chamber as a high-tech mixing bowl. Just like you'd mix air into cake batter, the compressed air mixes with fuel here. When the fuel and air blend together, they don't just sit there. A spark ignites this mixture, creating a powerful explosion. But don't worry, this explosion is controlled and happens continuously, not all at once like a firecracker. This rapid combustion produces a huge amount of hot gas. Imagine blowing up a balloon and then letting it go. Instead of a balloon zooming around, we have high-speed gas racing out of the engine. This jet of hot gas pushes against the back of the engine. According to Newton's third law, for every action, there's an equal and opposite reaction. So as the gases shoot out, they push the plane forward. It's like the principle behind a garden hose. When you cover the end with your thumb, water builds up and shoots out with force when you release it. In jet engines, that force from the hot gases is what propels the aircraft forward at incredible speeds. And here's something else most people don't know. This combustion process happens constantly, dozens of times per second. It's what keeps the engine running smoothly and efficiently. So the next time you hear that roar of the engines during takeoff, just remember, it's the sound of controlled explosions propelling you through the sky. You might be wondering about safety. How can we trust something as complex as a jet engine? Well, let's break it down. Jet engines are designed with multiple layers of protection, or what we call redundant systems. This means that if one part fails, there are others ready to take over. Imagine you're riding your bike. You wear a helmet for safety, but you also have knee pads and elbow pads just in case. That way, if you take a tumble, you're still protected. Jet engines work the same way. They have backup systems in place for almost every critical component. For example, consider the fuel system. If one fuel pump stops working, another pump kicks in to keep the engine running smoothly. And here's the surprising part. Jet engines are tested rigorously. They go through extreme conditions, like heat, cold, and pressure, to ensure they can handle just about anything. In fact, each engine is designed to operate safely, even if it experiences a failure. Statistically, the chances of a failure leading to an accident are incredibly rare. The aviation industry places safety at the forefront, constantly improving designs and implementing strict maintenance protocols. So when you board a plane, remember that you're stepping into a marvel of engineering designed to keep you safe. Each component has a backup, just like those knee pads when you're biking. That's why flying is one of the safest ways to travel. Next time you're in the sky, trust that engineers have thoughtfully planned for every scenario. It's just one of the many reasons why jet engines are incredibly safe. If you're curious about more aviation wonders, don't forget to subscribe. So how does a jet engine actually work? It's a remarkable process that might surprise you. Picture a giant vacuum cleaner. The engine sucks in a massive amount of air from the front. This isn't just a gentle breeze, it's a torrent of air rushing into the engine. Next, that air travels through a series of compressor blades. Imagine these blades as a set of powerful fans that squeeze the air down, increasing its pressure and temperature. This is crucial because the hotter and denser the air, the more efficient the engine can be. Then comes the magic moment. The compressed air mixes with fuel. Think of it like adding seasoning to a dish. When the fuel ignites, it creates a high-pressure explosion. This is where the real power happens. The hot gases rush out the back of the engine, and according to Newton's third law, for every action there's an equal and opposite reaction. So as those gases shoot out, they push the plane forward, generating thrust. And here's the surprising part. This process happens so quickly and efficiently that it allows jet engines to propel large airplanes at incredible speeds while using relatively little fuel for the distance traveled. Next time you fly, remember this fascinating journey of air, compression, ignition, and thrust. It's this intricate dance of mechanics that keeps millions of passengers safely soaring through the skies every day. If you enjoyed this insight into aviation, consider subscribing for more.